All right, so the next thing that I want to do here is to discuss the idea of variable logic, but show you what it's like when it has to do with well, you already know how to do scales, but how do you do it sort of with like moves, right? Because moves are going to be a little bit different when you're dealing with vectors, and how do you structure it? So what I'm going to do is look at these secondary panels here, and I'm going to just basically reduce, I'm going to reduce a panel within it, and then I'm going to kind of just move it around so that it has a different position, and then I'm going to trim it out. Okay, so the way I'm going to do it, I want to kind of follow along with the offset idea here, right? Whatever I did right here, how it's kind of evenly offset on all edges, I want to do that again, and then I'm going to trim it out to get started. So I'll just copy this here and pull it upwards, start a new part of my definition. Except now, instead of the rotational surface that I should be working off of and deconstructing, I'm actually going to go back to this surface right here, surface 4 point, the one from the originals. So I notice that I kind of have a lot of stuff going on around here. So I'm going to pull this down actually over to this side and override that surface connection. Oh, actually I need to deconstruct it first. Sorry. Go to Surface and Analysis and Deconstruct BREP. Go ahead and plug that one in. And then take your edges and plug it into curves. You can now, or should now, be able to turn those off. Well, maybe not that one. Oh, no. What are you doing? Why are you doing that? Huh. Alright. Cool. So this gives us an added challenge. So what's happening with this is it looks like the direction that it defaulted to, while the other one, it defaulted to the direction of the plane of the surface. In order to do the offset, this one, it looks like the plane that it's offsetting in the direction of is the XY plane, because notice how it's kind of jumping off of the geometry here in locations like this. So I'm going to try to reset it specifically to that plane, the plane of the surface itself, and I'm hoping I might even be able to just plug the surface in. I've never tried that. Let's try. I'm going to try that real quick. There we go. All right. So it looks like if I just plug the surface into the plane, it reads that as the plane of operation. So that's good. That was a guess, by the way. It just happened to work. But there is a difference. And actually, this is what I expected to happen last time, but it didn't. And so I don't know why it clipped the corners last time. But notice how the corners here are sort of fishtailed, right? It offset the curves properly, but it didn't trim them. It didn't offset a polycurve. It offset each individual curve. So at this stage, I don't know why. I wonder if I change that. It's reading as sharp, so it should be trimming. Anyway, so if this happens, we have the ability to identify the points at the intersection, which we can use to reconstruct the new either polycurve or surface, right? Because we're essentially getting a surface out of this anyway, so it's not really an extra step. So what I'm going to do is just take these curves. They come in packs of, they should be coming in packs of 3. Oh no. Oh no. That is weird. Oh, because it doesn't have a plane. 3 times. Okay. So that's actually a really good point. So what I'm thinking is like these should be coming out in packs of 3, right? Because when I grabbed the edges, they come out in groups of 3. So when it offsets them, no matter how it offsets it, it's supposed to offset them in groups of 3. Now, when I plugged in the faces as the plane of operations, it looks like what's happening is each of those particular curves is being offset on one face. So I think that's what's going on. 15, 45, we have 45. Yeah, sounds like that to me. Yeah. Hang on, I'm just trying to figure out the best way to split that up. All right, branch path indices. Yeah. All right. Faces. Because it is the same number of faces, maybe I can just repeat it 3 times. I'll try that. So let's give that a shot. So I'm going to go to sequence, repeat data, and I'm going to repeat faces 3 times. Okay. So now it's reading it in groups of 3. So when I plug that in to planes, still. All right, get rid of that, get rid of that. So graph won't do it. It's got to be in the tree somewhere. Hang on. Okay, so I'm hoping this is going to do what I need it to do. Basically, I'm partitioning the list of faces into groups of 3. So let's try plugging the chunks of 3 into, although there's 45 of those, there's only 15 of these. Well, let's give it a shot. No. Go! Alright, hang on. Okay, so this is what I did after playing around with a bunch of different things. I cannot figure out why it wasn't trimming the corners, but what I did was basically just did exactly the same kind of modification that I did all the way up to the rotation, all the way up to the offset. Okay, so I just took this whole thing. I took offset, I took deconstruct brep, rotation, the radians, but not the series, item, its slider, deconstruct brep, and I plugged that whole thing into the surface 4 point to give me a new offset. Now it flipped the direction of the offset from negative to positive, but it gave me exactly the same result. So my guess is that for some reason the surface that's being, or the edges here that are being, the surface that's being modified from surface 4 point is being changed in some way when it gets rotated into a different kind of surface, right? It's not registering as a regular surface or maybe brep or something like that. So it's a different kind of surface after it's been rotated. Maybe it turns it into a poly surface when it's rotated, in which case when we deconstruct it again right here, then you're deconstructing a poly surface. So just to quickly test something, now that I've thought through what my suspicions are, you can kind of look at the data that it's giving you. And so if I look at my edges off of the original surface 4-point, they are line-like curves. And I suspect that this is going to be different. Oh, no, it's not. So those are trimmed surfaces. Those are trimmed surfaces. I'm fascinated, guys. I have no idea what's different. Anyway, but, you know, when in Rome. So I borrowed this down here, and so there we go. We're going to use this. And so just, you know, go through the process of copying that down and turn this into a surface. And make your offset a little bit larger than the 3 inches on this one. And then we'll get going on the last component of the day, which is moving it around with variability in 3D. Questions? None? Okay.